So in this video, in Unit 3, I talk about domain and range, but I just want to kind of do a little bit more in range because there's a few questions in my MathFast Plus that ask for the range. If you want to remember, go back and listen to my lecture on Unit 3 to get more in depth about domain. Then you have the understanding about domain, but just in this particular, we're just going to be talking about finding the range. So just to kind of recap, remember to find a domain, there are three different cases that you are draw like a red flag. If you have a fraction in which the denominator cannot equal zero, because if the denominator equals zero, say for instance the answer is 5, 5 minus 5 is 0, and you cannot do 3 divided by 0. That's called undefined. So what we're trying to say is for this domain for this function is it can be all the numbers, all real numbers, except for the 5. So you'll go from negative infinity, comma, 5, and then both of those are going to be in parentheses, and then you put a union sign, and then it's going to be 5 to positive infinity. So you can have that's what the interval is going to look like. So you can have all those numbers except for 5, which is make this one, this answer right here true, or you get an answer or solution. For square roots, remember what I talked about in the lecture that you cannot have a negative inside a square root. So that's why we have it greater than or equal to 0. Yes, it can be equal to 0 inside the square root. It just has to be a positive number. So anything greater than 0 has to be a positive number. And then when we have even roots, you just have greater than 0 because it has to be positive because of the square root, and then it cannot be equal to 0 because it's in the denominator. Here's an additional video that I added to my lecture, this slide here, so that kind of help you more as far as finding the range. But I want to kind of go through two options to help you find the range. So for this particular one, I think option one is if you were to graph it and look at it in your calculator, then the graph can tell you the range and the domain. Remember, range deals with the y values. That means looking at this graph from the bottom to the top. So these are the two questions I do for finding the range. How far down does the graph go? How far up does it go? By just looking at it, we ask ourselves, how far down does this graph go? It kind of stops here, but this little arrow means it continues down on forever. That's why we say the range going down is going to be negative infinity because it just continues going down all the way here. How far up does it go? Well, it goes up in this direction to the positive direction for infinite because of this little arrow here. So the range is going to be all real numbers. So what does that mean again? All real numbers. The answer is all real numbers because you can use any number that you want. It's going to make this graph true. You can go up to positive infinity, you can go down to negative infinity. It does not matter. The range is going to be from here. I put this little these green little bars here because you kind of want to think about the domain and range. You're trying to see if you can box it in. And this one here, we're not going to be able to box it in. So the range is not going to stop at 4. It's not going to stop at -5 around here. Again, it's going to continue past this line, past that line, in that direction. So that's why it's going to be all the real numbers. So all the numbers, all the way up here, all the way down here. This one here is a little different. We can't say for the range to be all the numbers. Remember, if it has to be all the numbers, it means all the numbers up and all the numbers down. But this graph does not go down. Where does it stop at? So I draw this little red line here showing you that it stops at -4 on the y. So because it stops at -4, my question is again, how far down does it go? Looking at here, because it goes down to the -4, so this is where we're going to put in, and this equation doesn't match this problem. It's supposed to be, it's not drawing the scale. But anyway, for this one here, because it goes down to -4, -4 is going to be the answer as far as how far down does it go. Now, how far up does it go? Well, this one here, you can see is going in the upward direction with these little arrows, meaning going into infinite, which means the positive. So how far down it goes to -4, and it gets a bracket because it goes through it. Brackets mean that if it goes through it or you include it. Infinite, going up to positive infinity. Infinite, all infinite signs always gets parentheses because you can't include that number. There's no way you can include an infinity because it goes on forever. So that's why they always get parentheses. So looking at this one again, how far down does it go? So it goes down. Look at these arrows here. Here, it does not stop at -6. So we just don't, we're not going to put -6 as far as how far down it goes. It goes down forever to negative infinity. That's why I say negative infinity here. How far up does it go? Well, the up part, it stops at the 1 on the y-axis. So it goes all the way up to 1. It doesn't go to positive infinity all the way up here. How far up does it go? It doesn't go to positive infinity. It stops at 1. So that's why this one's going to be parentheses, negative infinity to comma 1 bracket, because it kind of goes through the 1 once we draw an imaginary line at y equals 1. So that's option 1 by just looking at it. So if you're able to have your equation, you can put in your calculator, hit zoom 6. Sometimes you might have to hit zoom 0 to kind of mess with the dimensions, but usually the standard use 6 will help you figure out how far down does it go, how far up does it go by just looking at it, and you'll be able to choose your answer on Math++. So option 2 is we're going to take the equation and we're going to find the inverse of that equation to find the range. Because not all the graphs you'll be able to look at the graph and you can clearly tell that it goes through 1 or it goes through -4 here. It won't clearly tell you that. So this is where we're going to take the equation and we're going to find the inverse, and we're going to do the exact same things is finding the 3 cases to figure out the domain, because the inverse of the function is actually the domain. So I explained that a little bit more in my example. So in my Math++, this is what a problem would look like uh, for finding domain and range. And again, I'm just going to go through the range, but we already know if you look through my slides, we have a fraction and a square root. So for this one here, we know we have to set it greater than 0 when we're trying to find the domain. And then whatever that would be, that will give you the domain. So for this particular one, I got an example here. So if we wanted to find the domain and range for this one, again, we're going to just set the bottom part, the denominator. Let me get my pen to work right. So it's 5 minus x. So we have 5 minus x greater than 0. So this kind of goes back here. We have to set it greater than 0 for this one. Then we're going to solve. Subtract 5 on both sides. That cancels. We have negative x is greater than -5. And to get rid of this one, this is an understood 1 to be in front of here. So to get rid of this -1, we can divide both sides by 1. That this way, this will cancel. And we have x is, and then anytime you divide by a negative, understand that this has to switch. This inequality sign switches. So we're going to flip this here, and this is going to be, these two negatives cancel out, and that's going to give us the negative +5. So for this one here, we will go to whatever your problem is in my MFS Plus and figure out which one symbol matches our answer for this one. Now for the range, I showed you before in this previous video that if you put in your for option 1, you can put in your calculator this equation here, and then kind of figure out how far down does it go and then how far up does it go. Make sure it's in that order. How far down is first, then how far up, and it gives you the range. But to do it by hand, what we want to do is this f of x represents y. So we have y is equal to and negative 9 so negative 9 square root of 5 minus x. And what we're going to do is we're just going to switch the y and the x. When we're trying to find the inverse, the f of x, so this will be inverse of x. When we do the inverse, all we do is going to take the y and the x, and we're just going to flip-flop them. So x will be over here now. We have negative 9 over the square root of 5 minus y this time. And we're just going to solve for y. Because once we solve for y, then we're going to ask ourselves look at the same picture as far as the three cases and figure out what the domain is for the y part. The same exact way. We just look at these three cases and figure out the domain. So it's pretty much the same thing. Once you switch the x and the y together and then solve, you just asking yourself the same question. So let's go ahead and try to work this out. The first thing we want to do is we're going to multiply. To get rid of anything in the denominator, we're going to multiply it by itself. So we're going to times this whole thing by the square root of 5 minus y. And what you do to one side, you also have to do to the other side. So you have the square root of 5 minus y over here. So that way this here will cancel out with this one. And we multiply together. Now you don't have to distribute anything, just kind of leave it separate like it is. So we just have the square root of 5 minus y x. So we just leave it just like here, these two being multiplied together, just leave them like that. And it's equal to negative 9. So because these being multiplied together, if I'm trying to solve for y again, I want to get this y by itself. So I got to remove this. If these being multiplied together, I'm going to do the opposite, which is division. So divide by x, divide by x. That way these guys cancel out. So over here, we're just left with the square root of 5 minus y is equal to negative 9 over x. Now, how do we get rid of a square root? We're going to take the square of both sides and that cancels out the square root. So over here, this square root cancels out with that square cancels out with the square root, leaving me with just 5 minus y. And you can distribute that in if you want like. There'll be 81 over x squared. So 9 times 9 with the square, when you square it, it gives you 81. And then you do the square with the x, it gives you x squared. So now we're going to move the 5 over. So we're going to subtract the 5, do the opposite again. That way, these cancel. Then over here, we're left with negative y is equal to 81 over x squared minus 5. Now we got to get rid of this negative in front, so we're going to divide everything by negative 1, which changes all the signs. So if you divide this by negative 1, that puts a negative here, and that puts a positive here. So that kind of changes the signs once you divide everything by the negative 1. So negative 1, negative 1. So that changes the sign. So our final problem, once we set equal to y, is going to be y is equal to negative 81 over x squared plus 5. Now again, this here is a fraction. I'm not necessarily concerned about when I find the domain of negative 81 over 5. That doesn't concern me going back to my slide because again, all I'm really focusing is on what's in the denominator. So for this particular one here, I'm just focused on this x squared. And you have to keep the negative with it. So we do the whole negative x squared. And remember, it has to be greater than 0. because we want it to be a positive, because remember we was working with a square root before, so we got to keep that positive. To get rid of the negative, again, we're going to divide everything by -1. Remember, by dividing by a negative number, this inequality sign gets flipped. So now we have x squared. We flip this one, 0. To get rid of the square, you can take the square root of both sides. It really is not going to matter, because taking the square root of this 0 is still going to be 0. But just for the fun part of it, we're going to do that to cancel this and this out, leaving you with just x and then 0. So for this particular one here, for the range, is going to be x is going to be less than 0. So we found the domain for this particular one here. We know that it has to be down here. It cannot be equal to 0, and it must be a positive underneath here. And then down here, once you switch it out, we see that our answer has to be less than, x has to be less than 0. So our choice would be the last one here. The function has to be less than 0. So hopefully that helped you with finding the range. And if not, please let me know so I can further explain how to figure out